Hello there, Mr. Sutton here, bringing you the IM373 Extra Practice number 1 solutions on right triangle trigonometry. To find the missing side on this triangle, since we only have one side and this is not a special right triangle, that means we're going to have to use SOHCAHTOA. So based on the angle, we have the opposite side that we're looking for, and they gave us the adjacent side, the non-hypotenuse leg of the angle. So if we have opposite and adjacent, that's the TOA part of SOHCAHTOA. So that's going to be tan equals opposite over adjacent. And then we've got tan of our angle, 57 degrees, equals the opposite side, the across side, so that's going to be x, over the adjacent side, 20. And to solve for x, I just have to multiply 20 by both sides. So we're going to have 20 times tan of 57. Let me use the calculator for this. So we've got 20, and we're multiplying that by tan of 57. Press enter. We've got 30.8 if we round that off to the nearest tenth. To find this missing side on this right triangle, since we only have one side and this is not a special triangle, it's not 30, 60, or 45, we're going to have to use SOHCAHTOA. So let's take a look at the sides that they have here. They gave us the hypotenuse, and this side over here is across from or opposite from the angle. So opposite hypotenuse, that's the SO part of SOHCAHTOA. So we're using sine equals opposite over hypotenuse. We have our sine of our angle, sine of 70 degrees, equals the opposite side x over the hypotenuse across from the right angle there, so 21. And to get x by itself, we multiply both sides by 21. So we have 21 times sine of 70 degrees. Let me do that on the calculator. So here we go, 21, and now we press the sine button, 70 degrees, plug into that, press enter, and that's 19.7. On this problem, we're trying to find this missing side. Since it's a right triangle and we only have one side and it's not a special right triangle, it's not 30, 45, or 60, let's use SOHCAHTOA. So we're looking for the hypotenuse, and we have the adjacent side, the non-hypotenuse leg of the angle. So that means that we're using, if we have A and H, we're using CA from SOHCAHTOA. So that's cosine equals adjacent over hypotenuse. So we have cosine of the angle, which is 27 degrees, equals the adjacent side. We just said that that was 29. It's the non-hypotenuse leg of the angle. And we're dividing that by the hypotenuse, which is x in this problem. To solve for x, we have to multiply x by both sides and then divide by cosine of 27. So basically switching cosine of 27 and x like so. So at the end of the day, we're just doing 29 divided by cosine of 27, which I'll do on the calculator. So 29 divided by, here's the cosine button. We've got 27 getting plugged in there. Press enter, and that's 32.5 rounded to the nearest tenth. On this problem, trying to find this missing side of a right triangle, we only have one other side, and this is not one of those 30, 60, or 45 angles, not a special right triangle. So SOHCAHTOA it is. Now, the sides that they gave us, this 22 side, that's across from the angle, so that is the opposite side. This x side is the leg of the angle that's not the hypotenuse, so this is the adjacent side. So if we have an opposite and adjacent, that's the TOA part of SOHCAHTOA. So we have to use tangent equals opposite over adjacent. So we have tan of 58 degrees, the angle, equals the opposite side across from it. We said that was 22, divided by the adjacent side, the touching side here, of x. And to get x by itself, we multiply both sides by x and divide by tan of 58. So we have 22 over tan of 58 then. And now it's time for the calculator. So here we go, 22. Divide that by, here's my tan button, of 58. No need to close the parentheses if it's the last thing, but we'll do it anyway. And then press enter. That's 13.7. For this problem, we're trying to find this missing angle. So since we have a right triangle and two sides, we can use SOHCAHTOA to find this. Let's take a look at which sides they gave us. They gave us the hypotenuse for sure, and the other leg of the angle that's not the hypotenuse is the adjacent side. So adjacent and hypotenuse, that's the CA part of SOHCAHTOA. So we have cosine equals adjacent over hypotenuse. So we can say cosine of x, the angle we're looking for, equals our adjacent side of 3 over the hypotenuse here across from the right angle of 9. And now I just need to do inverse cosine of 3 over 9 to get x. So let's do that on the calculator. On the calculator, for inverse cosine, I do secant and then cosine. And then I'll just put in whatever I need here, 3 divided by 9. So that's going to come out to 70.5, and that is in degrees. To figure out this missing hypotenuse in this right triangle, since I only have one side and I don't have any special angles like 30, 45, or 60, I'm going to have to use SOHCAHTOA. So I've got the hypotenuse that I'm looking for. Compared to the angle here, this side across from it is called the opposite side. So opposite hypotenuse, that's the SO part of SOHCAHTOA. So we have sine equals opposite over hypotenuse. That means we have sine of 24 degrees equaling our opposite side of 16 divided by our hypotenuse of x. And to solve for x, I basically switch the x and the sine of 24. I multiply by x and then divide by sine of 24. So 16 over sine of 24. Let's do that one on the calculator. So here we go. 16 divided by, and let me push my sine button, 24. Close that parentheses and enter for 39.3. For this problem, I'm trying to find this missing angle in a right triangle. Given that I have these two sides, I'm going to use SOHCAHTOA for this. And since I have the side across from the angle, so the opposite side, and the non-hypotenuse leg of the angle, the adjacent side right here, I'm going to use TOA, opposite and adjacent. That's the part of SOHCAHTOA I need. So this is going to be tangent equals opposite over adjacent. So I can say tan of x, the angle I'm looking for, equals my opposite side, which again is across from the angle. So it's this 10 side here, divided by the adjacent side of 22. To actually get x, I do inverse tan of 10 over 22, which I need the calculator for. So on my calculator, let's do secant and then tangent, and then 10 divided by 22. Close the parentheses, press enter, and that's 24.4, and that's an angle, so that's degrees. For this triangle, I'm trying to figure out this little angle in here. Since I've got two sides already and it's a right triangle, I can use SOHCAHTOA to find this. Now this 5 down here, that's across from the angle, so that's the opposite side. 11 across from the right angle is the hypotenuse. If I'm using opposite and hypotenuse, that's the SO part of SOHCAHTOA. So we have sine equals opposite over hypotenuse. So that means we have sine of the x that we're looking for equals my opposite side, which I just said was 5 because it's across from the angle. Hypotenuse is 11, so we're dividing by 11. And to actually find x, I need to do inverse sine of 5 over 11, which I'll do on the calculator now. So on the calculator, we're going to do secant sine to get sine inverse, and then 5 divided by 11, parentheses, and enter. That's 27.0 rounded to the nearest tenth. And this is an angle, so this is degrees. For this one, I'm trying to find this missing side. Since it's a right triangle and I have only one side and don't have 30, 45, or 60, it's not a special right triangle, I'll use SOHCAHTOA instead. So then we've got, based on this angle, we've got the hypotenuse and the adjacent side, the non-hypotenuse side. So adjacent hypotenuse, that's the ka part of SOHCAHTOA. And that means we have cosine equals adjacent over hypotenuse. So we can write cosine of our angle, 70 degrees, equals our adjacent side. We said that was the non-hypotenuse leg, so x, over the hypotenuse here across from the right angle, so that's 28. To solve for x, I just multiply by 28. So I have 28 cosine of 70, and now I need the calculator. So here we go, 28, and here's my cosine button. 70 gets plugged in. Press enter, and that is 9.6 if we round it off.